Hello, this video covers section 10.1 from your textbook. We have already learned one way of solving quadratic equations. We should all remember that we've talked already about solving quadratic equations by factoring, but we're also going to talk about two new methods for solving quadratic equations. So let's go ahead and get started. The very first thing I want to remind you of is what a quadratic equation looks like. And if we put one in standard form, it's this part that I just highlighted right here. It's the ax squared plus bx plus c. And what really sets apart a quadratic equation from a linear equation is that squared term. And what we know is that when we want to solve a quadratic equation by factoring, we want to set everything equal to 0. That's the important thing about it, because then we can use the zero factor property. And just remind what that says. It says if you take a product, a times b, and it's equal to 0, then that means the first factor has to be equal to 0, or the second factor has to be 0. Very simple idea, concept, yet very powerful when solving quadratic equations. And just a reminder that, like I said earlier, this is our note, that when we want to solve a quadratic equation using the zero factor property, we have to have it in that form, the equal to 0 form. So you'll notice in this first one, what do we need to do first? We have to get everything equal to 0, which means we got to add 2x to both sides. Now, why did I choose to move the 2x to the left side as opposed to the 5x squared to the right side? Well, we generally want our squared terms, our ax squared terms, to be positive. And if we move the 2x to the left side, that gives us a positive 5x squared still. We haven't changed that one. Plus 2x equals 0. And now we want to try to factor, what's the first thing we try to do when we factor? What do we always try to do first? We should ask ourselves this. Can we factor out a GCF? And in this case, yes, we can pull out an x, which leaves us with 5x plus 2. That's equal to 0. Now, what I'd like to remind you of here is that sometimes we get in the habit of just like taking the opposites of what we see inside here, but that doesn't really work when it's a binomial like 5x plus 2. It's not as obvious of what x is. So the way we go ahead and solve this equation is we set the first factor equal to 0, which is the x. X has to equal 0, or 5x plus 2 has to equal 0. And the first one, that's pretty much already done, but the second one, that's going to require some more work. So I'm going to come back up over here. If I have 5x plus 2 equals 0, then after subtracting 2 from both sides, we'll have 5x equals negative 2, which means x equals negative 2 divided by 5. So we have two answers. We have x equals negative 2/5 and 0. And that's how we solve a quadratic equation by factoring, and that should look familiar to all of us. We've done this countless times this semester, but just to review, this is a method for solving quadratic equations. So now ask yourself, with the second one, is this equation one that's in our form that we need, the ax squared plus bx plus c equals 0? Your answer to that question should be no. First of all, there's a 40 on the right hand side, and then we have these parentheses in here. So we need to distribute. X times 13 is 13x, and we need to take x times negative x. Negative x squared equals 40. Okay. Now notice here, in its current form, we got stuff on both sides, but also the negative, it's a negative x squared. The x squared is negative. We would prefer to be that positive because it makes the factoring process a whole lot easier. So I'm going to go ahead and move all this stuff over to this side. That means I need to add x squared to the right side and subtract 13x to the right side. I need to do the opposites. So this is really going to be 0 equals, and let's go ahead and write the correct order here. Let's write x squared minus 13x plus 40. So now we can factor. Of course, we'd have x minus 5 and x minus 8, which if x minus 5 equals 0, that means x equals 5, and if x minus 8 equals 0, x equals 8. So our answers are 5 and 8. Again, this is nothing new, but these are a couple of nice examples just to remind us how to solve quadratic equations by factoring. Now let's go ahead and pause the video, and you should be able to do self-check 1 now. Solve a quadratic equation by factoring. Alright, welcome back. Alright, so let's now take a look at another method for solving quadratic equations, and that's the method of extracting the square root. And so if I have equation, this is where we want to solve an equation that looks something like x squared equals 9. And before we get into something like that though, let's go ahead and look at the double sign notation. That's when we have this plus or minus in front of a number. And what that really means is plus a and negative a is represented in that statement. So if I had something like plus or minus 2, that represents plus 2 or negative 2. Alright, so let's take a look at solving an equation like x squared equals 9. Well, what I would like to suggest to you is that we could get rid of the squared by taking the square root. Now we know the equations, if we do it to one side, we got to do it to the other side, in which case the square root of x squared becomes x, and of course the square root of 9 is 3. And that seems pretty simple. We could check the answer. If we check it, we're checking it in our original equation, and we know that our answer 3, when we square it, is in fact equal to 9. That checks out. But what we also know is that negative 3 squared is equal to 9. So it's not just the positive 3, it's also the negative 3. So what I would like to suggest to you is that the answer is not just 3, it's plus or minus 3. And that's what you see in the square root property. In the square root property, we see that when I have something squared equal to a number, and this is a constant we're talking about here, some number, then the answer is always written as x is equal to plus or minus the square root of that number. That's the square root property. And so let's see how this works in an example. If I have something like 5x squared equals 60, the very first thing we want to talk about is getting it in the form that allows us to use the square root property. And the form that we need is this x squared is equal to some constant, which we don't currently have. We need to get the x squared by itself, and the thing we've talked about a lot is the isolating. So if we isolate by dividing both sides by 5, that does give us the form we need, the x squared equals 12. And now we can apply the square root property. We can square root both sides. So when we square root both sides, of course the left hand side, the square cancels and we just get x. And on the right hand side, this is where we need the plus or minus, and we need the square root of 12. And this does simplify. This simplifies down to plus or minus 2 square root of 3, because 12 is 4 times 3 and the square root of 4 is 2. And so we could write our answers like this. However, a lot of times in my math lab, they're going to want you to write it in the set notation. It's the negative 2 root 3 and the positive 2 root 3. On a test, I would be happy with either answer. This is more compact, which is why we get used to using the double sign notation, but you could write it in either way. Let's take a look at a couple different ones. Again, here this example B has that form, that x squared is equal to some constant, except the something that's squared, the x squared, is something more complicated. But still, why can't I just take the square root of both sides? There's no reason why I can't, because that square root will still get rid of the square. Left hand side becomes x minus 5. And remember, it's not just square root 5, it's plus or minus square root 5. And then we want to isolate the x. So I'm going to add 5 to both sides. This gives me x equals 5 plus or minus square root 5. And we typically, you will see the answer this way with the 5 in front of the square root 5. We typically will not see the answer as this, because sometimes it gets confusing if we're kind of sloppy with our writing about if this stuff is actually underneath the square root, which it's not. In fact, that's a good question to ask. Can I combine these two terms, the 5 and the root 5? Can I combine those together? Absolutely not. They are not like terms. So I have two answers here again. I have 5 plus root 5 and 5 minus root 5. And you could leave the answer like this, or you could write the answer as 5 minus root 5 and 5 plus root 5. And I think actually my math lab will ask for this format. So you should be familiar with being able to write your two answers like this as well. Okay, so we got one more of these. Let's go ahead and look at example C. What do you think we're going to do first to this one? And hopefully you're saying that, well, we need to isolate the x squared, so let's go ahead and subtract 25 from both sides. And something interesting is going to happen in this problem, because when I go ahead and apply square root property, when I take the square root, left hand side of course becomes x, but the right hand side becomes plus or minus the square root of negative 25. Now luckily, we talked about last chapter how to deal with square roots and negatives, and this we know we got to pull the I out in addition to the 5. So this is going to be plus or minus 5i. It's two complex solutions, or two imaginary solutions. So there we go, there's your answer. And this basically sums up the extracting the square method. There is an application in this section. Actually, there's a number of applications on your homework that you should now be able to solve. Let's go ahead and take a look at a problem like one you might see in your homework. It says a circle has an area of 20 square centimeters. Find the radius of the circle rounded to the nearest tenth of a centimeter. So let's go ahead and write down what we're given. This is a good way to start with any application problem. We've done this many times this semester. If we know that the area is 20 square centimeters, and remember area, this is the area of a circle, and it's asking us to find the radius. What is the radius equal to? We just talked about circles in section 13.2 a little while ago. We should all know what the radius is of the circle. And so I guess the next question we want to ask is, well, which of these formulas up here are we going to use? Are we going to use A equals side squared, the area of a square, A equals pi r squared, the area of a circle, or A equals 1/2 base times height? And since we're talking about a circle here, we are going to use the middle formula. So we're going to start with the fact that we know that the area of a circle is pi times radius squared. And look at what we're given. We're given A. We want to find radius, and radius is, of course, the variable r. So what do? We plug in what we know and solve for what we don't know. So we know that A is 20. That's all we know. Can I solve something like this? Well, this is almost the form that we've been solving, the form where we can extract the square. We have something squared, and we need it equal to some constant number, and we don't have the r squared isolated, so the first thing we need to do, divide by pi. So if you divide by pi, pi's cancel on the right hand side, we get 20 over pi equals r squared, which if I apply the square root property, we end up getting that r is equal to plus or minus the square root of 20 over pi. Now if we're talking about a radius, which is a length, do we really want to consider the negative answer? And your answer to that question should be no. So we're not even going to do the plus or minus. Most application problems we're not going to consider the negative answer because it doesn't make sense when we're talking about distances. So then we should be able to then calculate this. Go ahead and pull out your calculator. Okay, so in your calculator, you hit square root. And then inside the parentheses, we'll just take 20 divided by, and pi is over here right underneath the clear button. You have to hit second pi. Close your parentheses and press enter. If we round to the, it says in our directions here, round to the nearest tenth, that's 1 decimal. So we are going to round this to 2.5. R is about equal to 2.5, and since our area was centimeters squared, our radius is going to be just centimeters. There you go. Alright, you'll see some more of those in your homework. Now the last method we have for solving quadratics is the method of completing the square, and I'm not really fond of this one in most situations because it gets really complicated if the middle term is not an even term, and or if there's a number in front of the x squared. So it really only works well in a couple of situations. Now if you move on to calculus or pre-calculus, sometimes this method is a little nicer to know for certain idea or for certain concepts you might get into. But for the most part, most of you are probably not going to want to use this method. I want to show it to you, and just keep in mind that on a test I will never ask you to use this method. Actually, on the test I will never ask you to use any method. I'm just going to say here's a quadratic equation and solve it, so you can use whichever method you like. Let me just show you how it works though. So if I have x squared minus 2x plus 5 equals 0, the way this works is what we're trying to do is get a perfect square so then we can apply the square root property. And so the way it works is we take our equation x squared minus 10x plus 5 equals 0, and we take the constant term and we get it over to the other side. So that changes this equation to x squared minus 10x equals negative 5. And here is where the completing the square part comes in. We want to add something to both sides that will complete the square. And in other words, make it a perfect square. And so here's the way it works. You take the middle term, is we take our negative 10 and we divide it by 2, which makes it negative 5. And then the second part is we square it. And of course, negative 5 squared is 25. So there's two things you always got to do with your b, if you will. This is b. It's the coefficient in front of the x. You first divide it by 2 and then you square it. So what we're going to do is we're going to add 25 to both sides, and this is why it's called completing the square, because we have now completed the square, because the left hand side factors to x minus 5 times x minus 5. which is x minus 5 squared, it's one of those perfect square polynomials. The right-hand side, negative 5 plus 25 is 20. And look what this looks like now. This looks like one of the problems we did earlier. It looks like the second problem under the extracting the square problem. It looks like example B here. So we can now take the square root of both sides. We can square root both sides, in which case the left-hand side just becomes x minus 5 because we got rid of the square, and then the right-hand side is plus or minus square root of 20. And if we add 5 to both sides, we get x equals a positive 5 plus or minus square root 20, which is 5 plus or minus 2 square root 5. You can simplify square root of 20 down to 2 root 5. That's your answer. There's two answers there. Right, so hopefully that makes sense. Again, I'm not going to ask you to do this on a test, but I want to show it to you. Depending on where you go in future classes, you might use that at some point. So I want you to be familiar with it. And the last thing we're going to do here is, if we know the answers, if we know solutions to a quadratic equation, can we go backwards? Can we come up with what the original equation was? And the way you want to think about this is you want to think about how we solve quadratic equations using the factoring method. When we end up getting our answers of x equals 3/4 and x equals 5, we got that from the zero factor property, which happened when we had some factor equal to 0. So what we do is we try to take this expression, x equals 3/4, and we try to get it equal to 0. And so the first thing we'd want to do is multiply both sides by 4, which makes the 4's cancel on the right hand side. So we have 4x equals 3, and then we're trying to get this side equal to 0, which gives us 4x minus 3 equals 0 if we subtract 3 from both sides. So again, now that we've kind of done this, remember this is the way we started when we solved an equation by factoring. After we factored, we took a factor and we set it equals 0, and then we moved up this way. Well, we're going now backwards. We're starting with our answer and going back. We're trying to figure out what the original polynomial was, the original quadratic. And so we could do the same thing with this one. This one's going to be a bit easier. If we just subtract 5 to get it equal to 0, that's x minus 5 equals 0. And so if we continue to work backwards, the step before this was that 4x minus 3 times x minus 5 was equal to 0. Is this kind of coming together? I hope it is. Again, if we were solving, once we had it factored here, we would take this 4x minus 3, set it equal to 0, and find that x was 3/4, and set the x minus 5 equal to 0 and find that x was 5. We're going the opposite direction. And so now here, if we FOIL this, you get 4x times x is 4x squared, 4x times negative 5 is negative 20x, negative 3x, positive 15 equals 0, which gives us 4x squared minus 23x plus 15 equals 0. That's our answer. So there's our quadratic equation that has solutions 3/4 and 5. And that does it for section 10.1. You should now be able to do all the first 3 problems on your self-check. Talked about what you're going to need for that. So thank you.